Hi everyone, today I'll teach you how instruction formats are classified on the basis of operands. Now on the basis of operands there are two ways to classify, either on the basis of number of operands or on the basis of location of these operands. First we'll see on the basis of location of operands. On the basis of location of operands, there are three ways to, these are classified into three different types. First, memory reference instructions. Second is register reference instructions. And third is IO instructions. What differs in all three is that in memory reference instructions, the operands are available in main memory. In register reference instructions, the operands are available in one of processor's registers. In input-output instruction, the operands are taken from the IO devices or the peripheral devices. Now these are three ways to classify instructions on the basis of location of operands. Now we'll see how to classify them on the basis of the number of operands. So on the basis of number of operands, these can be classified into four types. The first is three address instructions. Three address instructions, as its name suggests, will have three addresses in the instruction. So let's take an example for all of these. The example I'm going to be taking is to add two numbers. So in three address instructions, that would be written as add x a b, where we are assuming we have to store the result of a plus b in x. This would be same as storing in x the result of a plus b. The next type is two address instructions. Similarly, here would be two addresses in the instruction, and if we were to use the same example of adding two numbers, we'll write add ab. This would mean we'll adding a and b and storing the result in the first address, which is a. So a plus b will be stored in a. The third type is one address instructions. In one address instruction, one address would be given in the instruction and the other address is assumed to be the accumulator. So here accumulator is the implied address. So to add two numbers, since we can only use one address in one instruction, we'll have to use two instructions to add two numbers. So we'll say add a. This would means that a plus accumulator is stored in accumulator. We'll make sure the accumulator is 0 before doing this, and we'll say add b. This would store in accumulator the sum of b and accumulator. So at the end of both of these instructions, a plus b would be stored in accumulator. Now the last type is zero address instructions. In zero address instructions are used in stack organization. So we'll be using stack. So when we say we have to add two numbers, we cannot use A and B, we have to use only stack organization instructions such as push, pop and add. So what we'll do is, in data register we'll have A and we'll say push. This will push from data register to the top of stack A. So if I were to give an example, let's say this is the stack. Here are different things XYZ, and on top of stack now we have pushed A. Now if I write again from data register, if now there is B in data register, and we'll say push, this will again push from data register to top of stack B. So A, and on top of that now we have pushed B. Now we can simply say add, and this will add the top of stack to the next element in the top of stack. So in now we'll have A plus B. Now we can pop it out and use it at other place. So these are 4 ways to classify instruction format on the basis of number of operands, and we have already seen how to classify on the basis of location of operands. Thank you.